There are two things that you need to notice about the denominators of example number 7. First of all, they are not fully factorized. But secondly, the third denominator is not written in the reducing degree of x. So that is what I'm going to do in my very first step. As the first and second denominators were written perfectly in the reducing degree of x, in other words, with the highest power of x coming first, I'm going to write them down exactly as they were. But the third one had been written with the x cubed term, which is the highest power, last, and I want to write it first. And then continuing in a reducing degree, I write down minus 2x squared second, and then lastly, plus x. I'm now ready to factorize my denominators. In the first denominator, I have a highest common factor of x squared. And so factorize, that's going to be x squared, and then x minus 1 left in the bracket. There's a highest common factor of x in the second denominator, which leaves me an x squared minus 1 in the bracket. And lastly, there is again a common factor of x, which leaves me with x squared minus 2x and plus 1 in the bracket factor. You can see that only the first denominator is fully factorized, and so I need to continue factorizing in both the second and the third denominators. The second denominator has a difference of 2 squares in the bracket, which gives me 2 further brackets of x plus 1 and x minus 1. The third bracket is a trinomial, and when I factorize this, I'm going to get that it's x minus 1, x minus 1. Now my denominators are fully factorized. But did you notice that in the last denominator, I have got two x minus 1 factors? So that I can recognize what I need in my LCD, I'm going to rather write this as x minus 1 all squared. And so my last denominator, instead of being written as 3 separate factors, can be written as x and then x minus 1 all squared. I'm now ready to find my LCD. As my LCD is the most of all types of factors, I must have 2 of the x factors because there's an x squared, an x, and x squared is a greater degree for that factor. There is only one x minus 1 factor in the first two terms, but there are two x minus 1 factors in the last term, so I must choose the x minus 1 squared. And lastly, I still need to have the x plus 1 factor. From this, I'm able to work out my restrictions. My restrictions are that x cannot be equal to 0, x cannot be equal to 1, and x cannot be equal to minus 1. Now using my same LCD, I'm able to change the numerator of my fraction. When I take a look at my old factors in my separated denominators, I see that the first denominator had an x squared, and it had one x minus 1 factor, so its old numerator, which is 1, must still be multiplied by the second x minus 1 factor and by the x plus 1 factor. Going on to the second term, it had only one x factor, so it still needs a second x factor, and it needs the second x minus 1 factor. It already had the x plus 1 factor, so I don't need to multiply its old numerator by x plus 1. And moving on to the last term, I had a single x factor. I now need a second one so that I get to x squared, and it had both of the x minus 1 factors, so all that remains is for me to multiply the x times x plus 1. Now multiplying out my numerators, I find that I'm going to have x squared minus 1 from my first term. Distributing the x into its bracket, I get minus x squared plus x, and then going on to the third term's numerator, I get plus x squared plus x. When I add these terms, I get a final answer of x squared plus 2x minus 1 all over my common denominator.